Now for the basement. When calculating heat loss for the basement, we're going to do the same thing we've been doing, only a little bit differently. First off, we have to calculate infiltration. Now you'll note in the floor plan that most of the basement wall is below grade. It's a 7-foot 6-inch wall. 6 feet of that wall is below grade and only 1.5 feet of the wall is above grade. If you think about infiltration as air leakage in and out of a structure, you can see that it's pretty much impossible for air to leak out of the part of the structure that's below grade. So we only have to calculate infiltration for the part of the wall that's above grade. To calculate infiltration for the basement, you'd have to find the volume that's above grade. So you'd multiply the length of the basement, that's 55.5 feet, times the width of 25 feet, times the height of the portion that's above grade. That's 1.5 feet. If you multiply that out, you'll get a volume above grade of 2,081 cubic feet. Now note that 2 of the basement walls have windows. They're little, but they're there. That means you'll have an infiltration factor of 0.018. And your DTD, of course, is still 63. You multiply that out, and you'll have an infiltration heat loss of the basement of 2,360 BTUs per hour. Another area of difference when calculating heat loss for the basement is in the floor. Now, line 3 of your heat loss worksheet is used for floors, but line 4 is used for slabs. However, you'd calculate heat loss differently depending upon whether the slab is on grade or below grade, like it is in our basement. If the slab was on grade, like in a commercial building or on a slab-on-grade residence, you'd use line 4 of the worksheet. You'd have to measure the total perimeter of the exposed edge, since that's where on-grade slabs lose most of their heat, out through the edge. You'd then go to section 27 in table 3, and you'd pick the U value based on how much edge insulation you had installed. But our basement slab is below grade, so we only have to figure the downward heat loss. For that, we simply use the area of the floor, 55.5 times 25. That's 1,388 square feet. Next, we go to Table 3, Section 27, and this time we're going to look at line D to find the U value, and we find that it's 0.04. To calculate the heat loss, we'll multiply the area of 1,388 times the U value of 0.04 times the DTD of 63, and that'll give us a basement floor loss of 3,498 BTUs per hour. Next is the window loss. Now you see them, they're there. We have 1, 2, 3, 4, 5, 6. 6 windows. Each one of them is pretty small, but they're there. They're only 2 square feet each. That's a total of 12 square feet of window area in the basement. Let's put that down in our worksheet. We also see that the basement windows are a little bit different from what we had upstairs. These are single pane low E windows with a storm sash. We looked that up on table 3, section 4 for windows, and we see that under line B, the U value for this type of window is 0.418. We multiply that out, and we'll have a window heat loss for the basement of 316 BTUs per hour. Now let's do the transmission heat loss for the basement walls. Another big difference from the upper floors is that for the basement, we're going to have to do 2 separate calculations. One for the wall area that's above grade, one for the wall area that's below grade. The reason we do that is because Mother Earth is an excellent insulator, and the below grade portion of the walls will lose heat at a much lower rate than the above grade portions. Now remember when we calculated the basement infiltration, we learned that 1.5 feet of the basement wall was above grade, 6 feet of the basement wall was below grade. Now that's true for 3 of the 4 walls. The basement wall that's adjacent to the garage is completely below grade. Hey, but you know what? For simplicity's sake, we're going to make our lives a little easier, and we're going to use the 1.5 foot to 6 foot ratio for all 4 walls. Our final heat loss for the basement will be a little bit exaggerated, but not by very much, and it's going to make our math a heck of a lot simpler. Okay, let's calculate the above grade area first. We have 2 55.5 foot walls, and we have 2 25 foot walls. Add them together, you get a total of 161 feet worth of outside wall for the basement. Multiply 161 times the 1.5 foot height that's above grade, and you get a total exposed wall area of 241.5 square feet. Now before you go putting that into your worksheet, remember we have to take out the window area. So subtract 12 square feet from the 241.5, and you'll have a net wall area of 229.5 square feet. To find the U value for that portion of the wall, we're going to check Table 3. Now this time, we'll look up poured concrete walls, which is in Section 18. We see from our info sheet that the wall is made up of 8 inches of poured concrete with 2x4 studs, 16 inches on center. There's 3.5 inches of insulation, a vapor barrier, and 1/2 inch drywall. If we look up line C in Section 18, we find a U value of 0.083. When we multiply that out, we get 1,200 BTUs per hour for the above grade portion of the basement walls. Now we do the heat loss for the below grade wall area. The basement is 6 feet below grade, and we multiply by the same 161 linear feet of outside wall times 6 feet and get a wall area of 966 square feet below grade. Now going back to Table 3, Section 18, line I this time, we'll find that the U value for the same type of wall more than 5 feet below grade is 0.046. Again, we multiply it out and we get 2,799 BTUs per hour for the below grade portion. Now when I total up all of the heat losses from the basement, I get a total of 10,173 BTUs per hour. If you were to add in the heat loss of the first floor, we'd have a total heating load for the house of 30,609 BTUs per hour. In your customer's home, you'd go through and follow the very same procedures for every room or space in the house. Table 3 tells you the transmission heat loss factor to apply for just about every type of building material or construction you're bound to run into. There are specific ways to handle basements and walls below grade and cold partitions. The Heat Loss Calculation Guide H22 contains all of the details for determining heat loss in virtually every situation. This book's inexpensive and it's well worth having. If you consider yourself a heating professional, you really need to have this guide in your library. As I said at the beginning of this course, one very important difference between an amateur and a professional is that an amateur guesses while a pro measures and does the math. The amateur hopes to get it right once. The pro has to get it right every single time. The H22 Heat Loss Guide is available from these folks right here. Okay gang, that concludes our course, Hydronics Design. It all starts with heat loss, Part 1. There's no final exam for this course. If you followed along, paused the lessons to do your own calculations, then checked your answers against ours, and then hunted down if and when your numbers were off, then you've already taken the test and you've already passed it. If you didn't go through all the exercises, then I doubt that you've gotten the necessary proficiency to do your own accurate room-by-room heat loss. I suggest you go back to wherever you left off and go through the course in detail. Now in Part 2, we're going to show you a couple of new things. First, we'll calculate heat loss for the exact same sample house using Taco's FlowPro Designer software, which is available for free to you and only to you as a member of the Taco FlowPro team. Then we'll cover some of the odd, unusual, and challenging situations that you can run into and show you how to work them out in the same logical, straightforward manner that you calculate heat loss for a typical home. In the meantime, I invite you to visit the FlowPro neighborhood. You can get there through the FlowPro team website. The neighborhood is a great place to hash over what you learned here with other plumbing and heating professionals. You can ask questions, you can answer questions, and share some of the things you've learned by applying this heat loss lesson out there in the field. In fact, there's a group devoted specifically to discussing heat loss analysis. Well, that's it for now, gang. Thanks for attending FlowPro University. Come on back for all of the courses. They're all designed to help you get better. Have a good one.